Okay, so we are at chromatography right now. So chromatography, it's a very interesting procedure. So for chromatography, you must be able to describe what chromatography is and how to interpret the chromatograms, and also understand what locating agent is. So over here, chromatography, right, I'm going to separate two or more components within a solution, and it's very, very small amounts, okay? Very small amounts. So for example, pigments in plants, like for example, we all know purple consists of red and blue. So how do I separate the red and blue color? Or again, dyes in paints and coloring in food. So currently we look at all this, right? It's that it's colored compounds. So can chromatography actually separate non-colored compounds? The answer is yes, it can separate non-colored compounds. So these compounds, right, will be separate onto what we call a chromatogram, and this is how the setup looks like. So the separation of the substance is based on its relative solubility in the solvent. Right? So what is the solvent? The solvent is the thing that we dip the chromatogram in, the one that goes up. Right? So it depends on the solubility. The more solubility the substance, the higher it will travel. So you can imagine like the solvent will move up and then it will slowly pull the rest of the substance with it. The more soluble the substance is, the higher the substance will travel, or the further the substance will travel. So as what I said, color substance can also be identified using chromatography, and we use this thing called a locating agent. So in your textbook, there are some examples of locating agents, right? And these locating agents will react with the colorless substance to actually form a color, and this color will make it visible. So why do we use locating agents? Is actually to make colorless substance colored in order for them to be visible. So there's this very special thing about chromatograms, which is called the RF value, right? The RF value. So let's look at these two chromatograms. They are actually of the exact same substance. So over here, this is what we call the solvent front. The solvent has traveled all the way up from this solid line all the way to this dotted line. But the substance have only traveled from the solid line here. Now, this is the exact same substance, but I left it inside the solvent for a while. So the solvent traveled further from this solid line higher to this dotted line, right? So therefore, the substance will also travel a bit higher. Then how do I know whether these two substances are the same thing? So we need to calculate the RF value. So what is the RF value? The RF value is actually the ratio between the distance traveled by the substance, which is this red arrow here, the distance traveled by the substance, and the distance traveled by the solvent. So as you can see in the one on the left, the red line is shorter, but the blue line is also shorter than the one on the right. So it's looking at a ratio, right? And this ratio is called the RF value of the substance. And a substance will have the same RF value in the same solvent. So for example, let's say the drug penicillin will have a particular RF value in water and a particular RF value in ethanol. And this RF value can be calculated as the ratio. So this RF value, right, wouldn't change even if, let's say for example, I run the chromatogram for a longer time. Right? How do we calculate it and how do we show? So let's look at one on the left. So the chromatogram after a period of time, right? So the distance traveled by the substance is 3 cm. So we measure a ruler. This is a 3 cm. And the solvent travels 4.5 cm. So 3 cm ratio over 4.5 cm is 0.67, 2 decimal places. Right? If for the same substance, I run it for a longer period of time, right? The distance traveled, the solvent front will be further. So instead of 4.5 cm, it's 5.2 cm now. And the distance traveled by the spot is now 3.5 cm instead of 3. But the ratio will still be 0.67 cm because it's the same substance in the same solvent. So therefore, we can say that the RF value does not change as long as the chromatography is conducted in the same conditions, means same temperature and same solvent. The same substance will always have the same RF value. And this actually allows us to identify the substance very easily. Okay, so what can we use chromatography for? Chromatography is also used for a lot of things, like to separate the components in a sample, is to identify the components within a sample, to identify different substances, and to determine whether the substance is pure. Right, so it's commonly used in like drug detection, urine tests, right, to check whether things we have created is pure. Right, so we have more practice for all of you, so I hope this has helped a little. Right.